Welcome! In this video, you'll learn how to solve the following College Board practice problem. If you find this video helpful, please give it a thumbs up and subscribe for the newest SAT math problems. Lastly, if there's something you have a question about, feel free to ask it in the comments below. Without further ado, let's do this. If 3x minus y equals 12, what is the value of 8 to the x power over 2 to the y power? First, they give us an equation, 3x minus y equals 12. Two variables.
Zoinks!
Then they give us 8 to the power of x over 2 to the power of y. It also has two variables.
Double zoinks!
How are we going to use this information to find the value of 8 to the power of x over 2 to the power of y? First things first, when you're being asked for the value of something, they generally want a number. Since we are presented with statements with multiple variables, we need to combine them and use substitution so that the variables can be taken out. Take them. So as we approach this problem, we're going to look for opportunities to simplify or rewrite the information so that we can more easily use them. The first thing we should simplify is this fraction, 8 to the power of x over 2 to the power of y. But with the way it's currently written, we can't do anything unless they shared a similar base. And they can.
Excellent!
We can rewrite 8 as 2 to the power of 3, since 2 to the power of 3 is equal to 8. From there, the resulting power 3 will multiply with the original power x, leaving us with 2 to the power of 3x over 2 to the power of y.
But wait, there's more!
Since both the top and bottom now share the same base, we can join them together into a single base and power by grabbing the power from the bottom and subtracting it from the power on top. And that's going to leave us with 2 to the power of 3x minus y. Now, we just need to get rid of those variables. We'll do this with the help of the equation 3x minus y equals 12. Alley-oop! Let's rearrange this equation so that we can more easily substitute it into the other statement. Since 3x is positive in this equation, let's move the y to the other side by adding y on both sides. From there, let's take this identity of 3x and replace the 3x in the power. Next, simplify the like terms. That's going to get rid of the variables and leave us with 2 to the power of 12, the final answer. For all you smarty pants out there, you might have seen something secret. Here it is. The equation was in the same form as the power of 2 that we ended up with. So we could have just replaced 3x minus y with what it equals based off the equation. 12. If x is greater than 3, which of the following is equivalent to the expression below? Now that we've read the problem, let's note the key rules and information. 1. X is greater than 3. This information is actually kind of useless. The only limitations to x that you should care about is making sure that x doesn't equal -2 or -3. The reason why? Well, if x equaled either of those numbers, we would end up with a 0 in the denominator, and that's going to be no solution automatically. So that's a no-no. Beyond that, they ask us to find something equivalent to this expression. What should we do here? If you guessed that we're going to make this expression simpler, you're 100% correct. This expression is ugly, but with our understanding of Algebra 2, we're going to give it a stellar makeover. The easiest way of approaching this problem is to join the fractions on the bottom. We'll make x plus 2 times x plus 3 the common denominator here, and multiply the missing factor to each numerator. From there, we'll join the fractions and then combine like terms in the numerator. We now have a single fraction at the bottom. The secret to moving on from here is to recognize that fractions are actually divisions.
Great Scott!
In this case, we have 1 divided by the bottom fraction. Now that it's written horizontally, we can easily see that all we need to do is flip the fraction and multiply. Now it's one solid fraction. Last but certainly not least, let's FOIL the top of the fraction. And that's our final answer. A line in the xy plane passes through the origin and has a slope of 1 over 7. Which of the following points lies on the line? Now that we've read the problem, let's note the key information. They said the line passes through the origin. That really means the line passes through the point 0, 0. They also stated that the slope is 1 over 7. How are we going to figure out what point is on the line with this information? They ask us to find the point that lies on the line. Since they didn't draw a line for us, we will find the point using the starting point and the slope. Drawing accurate graphs without graph paper can be kind of difficult. So I recommend finding other points on the line without a graph. I'll show you how using the slope. To find points, we need to leverage the slope they gave us, 1 over 7. This slope tells us that we can find the next point by going up 1 and to the right 7. You've probably heard the slope described as the rise over the run. This can get confusing if the slope is negative. So instead, I'll show you another way of interpreting the slope. A positive slope is the distance we travel up over the distance we travel to the right. And a negative slope is the distance we travel down over the distance we travel to the right. That's right, always to the right. Sorry, Beyonce. Let's grab the point and use our new understanding of the slope to find us some points. Since the line passed through the origin, we'll start at 0, 0, and then go up 1 and right 7. We're going to add 1 to the y-coordinate of the point and add 7 to the x-coordinate of the point. We get the point 7, 1. Unfortunately, that's not one of the choices. So let's go ahead and apply the slope again, this time with a point 7, 1. That's going to give us 14, 2, which is the answer. Real quick, let's pretend we wanted to find a point that was to the left of the point we started off with. Let's use 14, 2 as a starting point for this case. If we wanted to find the point before the starting point, we will place a negative sign before the x and y coordinate transformations based off the slope. By doing so, we're going to end up with the point previous to the starting point, which is 7, 1. Remember that. In the equation above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? Now that we've read the problem, let's make note of the key information. B and C represent the price of beef and chicken. B represents the price of beef, while C represents the price of chicken. From there, X equals the number of weeks after July 1st. Let's figure out what we need to do. The last sentence reveals what they really want us to do, and that's set the price of beef equal to the price of chicken. Let's go ahead and bring in the full equations. Now that we've set the prices equal to each other, we can see that we're missing key information on both sides, X. So this is our game plan. We need to solve for X, and then plug it into either B or C, and the result will be the price when they are equal. Since we have x's on both sides of the equation, let's move all of the x's to the side with the largest number in front of x. That way we don't end up with a negative number when we combine them. So let's subtract 0.25x from both sides. That's going to leave us with 2.35 equals 1.75 plus 0.15x. From there, let's further isolate x by subtracting 1.75 from both sides. That's going to leave us with 0.60 equaling 0.15x. Since 0.15 is multiplying x, we will get x by itself by dividing 0.15 on both sides. Since there's a decimal here, we will need to move the decimal point over until this is a whole number. Once it's a whole number, we will move the decimal point for the number being divided. And that leaves us with x equaling 4. Now that we have x, let's plug it into B or C to find the price. We have two equations to choose from. B or C, which one would be easiest to simplify if we change x into 4? I gotta say B would be the easiest, since 0.25 is basically a quarter, and 4 quarters equals $1.
Cha-ching!
So let's replace x with 4 inside of B. First, 4 times 0.25 equals 1, giving us B equaling 2.35 plus 1. From there, let's combine 2.35 and 1, and that's going to leave us with B equaling 3.35. So the price of beef, when it was equal to the price of chicken, was 3.35. Hold up. Let's check our answer by plugging in 4 into C. If we're correct, it should end up equaling 3.35 as well. So we have 0.40 times 4, which equals 1.60. From there, let's go ahead and combine 1.75 and 1.60, and that leaves us with C equaling 3.35.
Nice!
The prices match. So our answer is correct. For the function g defined above, a is a constant, and g4 equals 8. What is the value of g negative 4? Now that we've read the problem, let's make a note of the key information they presented. First up, that equation, gx equals ax squared plus 24. Whenever you see an equation, you definitely want to write it down. We're probably going to have to use it to solve the problem. Next, they tell us that a is a constant. All that means is that a is just a number. And lastly, g4 equals 8. Let's figure out what we need to do with all this information. First things first, what does g-4 even mean? By itself, nothing actually. A statement like this is usually connected to an equation, since the number in the parentheses is what we would replace x with. In this problem, the equation that g-4 is connected to is gx equals ax squared plus 24. So g-4 actually means a-4 squared plus 24. Therefore, the goal with this kind of problem is to end up with g-4 equaling a number. However, we're missing a key piece of information, and that's a. Since we're missing some key information, let's circle back to the problem to see if there's anything that can help us out. And there it is. They told us that g4 equals 8. This means that when we plug in 4 into the equation, the result is 8. So let's plug in 4 and figure out what a has to be so that it equals 8. So if we plug in 4, we'll have 8 equals a 4 squared plus 24. So let's go ahead and square the 4. That's going to give us 16. So now we have a times 16 plus 24 equals 8. 16 times a can't do anything. So let's go ahead and subtract the 24 from both sides. That's going to leave us with negative 16 equals 16a. Let's divide by 16 and a equals negative 1. Awesome. So we have a. Let's plug it in to where we left off earlier. So now we're going to replace a with negative 1 and combine them all. So we have g-4 equals negative 1 times negative 4 squared plus 24. Let's start off by squaring negative 4. That's going to give us 16. From there, we're going to multiply the negative 1 to give us negative 16 plus 24. Now, this looks a little confusing, so let's figure this out by putting 24 over negative 16 and combining them the old school way. From there, we get 8, so g-4 equals 8. If a over b equals 2, what is the value of 4b over a? Is it a, 0, b, 1, c, 2, or d, 4? Hold on to your seats. We're about to get into this problem. Let's go. All right, so to start off this problem, we need to identify what is it that we're solving for. So first thing is, what is the value of 4b over a? And they tell us that a over b equals 2. All right, so obviously it looks like this a and b is over here, but it seems to be flipped over. So we're going to have to pick this apart or transform this in a way that we can see the a and b separately. So let's start by writing 4b over a. And since we want to turn this into something that looks more like this, or we're going to push it to the side. So what's currently happening between the 4 and the b? They're multiplying. So we're going to go ahead and rewrite this as 4 over 1 times b over a. We could have written it as just a 4, but since this is a fraction, we just want to get in the practice of writing this out as a fraction too, 4 over 1, since we're separating it. All right, so that looks a lot closer to this. So now let's take a look and let's go grab this out. So now let's go ahead and grab this and bring this out onto our workspace. And the difference here is that the A is on the bottom and the B is on top here. So we are going to change this up. If we were to flip over this A and B, what would we end up on this side? We will find that out if we go ahead and place this 2 over 1. So now that this is 2 over 1, if we were to go ahead and flip that over, this will be 1 over 2, which is totally fine because if you look at it, the B is still matching up and the A is still matching up. And what we did is totally legal. Any number, we can put a 1 underneath. That's still fair game. All right. So now that we have B over A equals 1/2, let's go ahead and substitute it. Replace this with that. So that's going to be 4 over 1 times 1 over 2. Here we can cross cancel. 2 and 2 into 2 is 1. 2 into 4 is 2, which is 2. Or we could have just multiplied across. So if we do that, we end up with 4 times 1, which is 4, over 1 times 2, which is 2. From there, 4 divided by 2 equals 2. So the answer is C! The formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. Which of the following gives P in terms of M, R, and N? Is it A, B, C, or D? Have your answer ready? Let's do this. The first step is understanding what the question is asking. We can find that here. Which gives P in terms of M, R, and N? This means that they want an equation where P equals some sort of combination of these terms, M, R, and N. Right now, the problem gave us M equaling this huge mess. So we would describe this as M in terms of R, N, and P. So how are we going to get the answer that they want? That's right. We're going to transform the equation so that P is on one side by itself, and these other terms, the N, the R, and the M, are on the other side. Now that we know what we need to do, let's figure out how to actually get P by itself. This equation looks pretty gnarly, but getting P by itself is quite easy. It becomes easy when we focus on how these terms, this whole mess here, how this whole mess is interacting with the P. So, what exactly is interacting with P? It's not each of these individual pieces. It's really the whole group that's interacting with P. And since this whole group is actually a fraction, let's replace it for now with a much simpler fraction. Let's say A over B. So now we have M equaling A over B times P. If this is just A over B, how would we get P by itself? We would need to multiply A over B times the upside down version of itself. Which is B over A. Since we're going to do that on this side, we will need to also multiply B over A on the other side. It's a rule of equations. By doing so, we're going to cancel out the a and the b on this side and end up with p equaling b over a times m. Since this is a little awkward to look at, let's go ahead and rewrite this where the p is on the left side and we're equaling b over a times m. Now that we have p by itself, it's time to change a and b with the numbers and letters that we had earlier. A equals r over 1200 times 1 plus r over 1200 to the power of n. So that's going to go on the bottom. B equals 1 plus r over 1200 to the power of n minus 1. So that's going to end up on the top, which gives us p by itself with the rest of the variables r, n, and m on the other side, thus giving us p in terms of r, n, and m. So what's the answer? You got it. B! On Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? Is it A, 9 MP, B, 20 MP, C, 5M plus 4P, or D, 4M plus 5P? On Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? Is it A, 9 MP, B, 20 MP, C, 5M plus 4P, or D, 4M plus 5P? Have your answer ready? Let's go ahead and solve this problem. The first thing we need to do is figure out what is this problem asking us. And that's going to be located in the last sentence here. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? The other way is by looking at the options here. It looks like we're going to have to create some sort of expression. And since we just read the last sentence, the expression is going to be the total number of texts that Armand sent plus the total number of messages that Tyrone sent. And that's going to tell us the total number of messages sent. That's this whole statement right there. Now that we have this expression to guide us in solving the problem, let's figure out how many messages or how many texts Armand sent. To do that, we'll need two things. The first is how often he texted, and then for how long was he texting. And we'll multiply this together. This setup is based off a very important equation that we all need to remember and know. And that is the total equals the rate times time. Here are some forms of this equation that you may encounter when you take your SAT. Now that you saw those forms, let's find the rates for this problem. The rate is usually written in the following setup. It's usually a number, the word per, and then some sort of time. And the word per can be replaced with the word a, every, each, and a couple more, but these are the main ways you'll see it. And so to find this in our problem, we can see that right here. Armand sent M text messages each hour. So our rate here is M texts per hour. The time, well, the time's easy to locate. It's just some sort of minutes, hours, years, months, whatever. In this case, that's going to be hours. So 5 hours. Nice. Right here, there's something very important that needs to match in order for us to figure out what this total is here. And that is these times. These times need to be the same type of. And while they may be the same for this problem, if they're not, it's going to require you to do some extra work. So just to make sure that you're well prepared for your SAT, let's look at a scenario where they don't match. Ready? Let's take a quick tangent. All right, now that we're back from that tangent, let's go and continue where we left off. Here, the total for A is M texts per hour times 5 hours. Since the times match, we're able to multiply directly. So M times 5 equals 5M. So that's the total for Armand. Let's find the total of Tyrone. Here, we found the rate, P text messages per hour. So that's going to be P texts per hour. And then the time is 4 hours. Here the times match. So the total is going to be 4P. Nice. Now that we have their individual totals, let's bring them together to get the final answer. And the answer is C. If x minus 1 divided by 3 equals k, and k equals 3, what is the value of x? Is it A, 2, B, 4, C, 9, or D, 10? Got your answer? Let's go ahead and dive into this problem. The first thing we're going to do here is look at what is the question asking of us. So that's going to be at the very end. What is the value of x? Alright, so where is this x coming from? Well, we have this equation. X minus 1 over 3 equals k. So whenever you're given an equation, most of the time you're going to have to use it to either change it or plug something in or both. And then what's the last piece of information? K equals 3. Great. So now let's go ahead and get started by writing down the equation. X minus 1 over 3 equals k, and we want to find what x is. So that means we want to isolate or get x by itself. Right now, what is currently involved with the x? What's currently bothering it? Well, we have this minus 1, and we have this 3 at the bottom. That's dividing. So we're going to have to move these items one by one to the other side and cancel them from this side. In order to do that, we need to do the opposite of what they're currently doing. So, and then that's one step, one thing. And then second thing is that we need to move. We're going to take care of the items furthest from x, which will be the 3, and then move into the minus 1. So think of it as like an onion. We're going to be peeling off the outer layers in order for us to reach the x and get it by itself. So let's go ahead and start with the 3. So the 3 is currently affecting both the x and the minus 1. So we are going to do the opposite of what the 3 is doing. What's the 3 doing? Well, it's dividing. So that means we're going to multiply both sides. So if we do that, these will cancel. So we're left with x minus 1 equals the k times 3 equals 3k. From there, we're looking at the minus 1. So we're almost there. We just have the minus 1. What's the opposite of minus 1? Plus 1. So we're going to add 1 to both sides. X equals 3k plus 1. Nice. Okay, so this here could have been the answer if they had asked us what is x in terms of k. But they didn't ask us that. They asked us what is the value of x, which means that we need to find a number. So here we have x by itself, and in order to figure out what x is as a number, we need to replace this k with something. We're going to replace the k with that 3, since k equals 3. So it's going to be 3, and we'll substitute that, replace it with the 3, plus 1. 3, parentheses 3. Here, when you have a number and a parentheses next to each other, they are going to multiply. So it's going to be 3 times 3, which is 9, plus 1. 9 plus 1 equals 10. And that's our answer. So the answer is D. In this scenario, we have a rate and a time. However, the times in each of them are not the same. So in order to solve this problem, we must make the times equal. To do so, let's start with the minutes. We're going to change this time, minutes, into hours. To do so, we're going to use a tool that we learned in chemistry called the conversion table. I'm not sure if that's the real name, but we're just going to go with it. And what we're going to do, we're going to draw a plus sign like this, or a large plus sign. We're going to write 90 minutes here, what we're starting with, and then we're going to write down that same time indicator on the bottom on this side, and then our desired time, which is hours. And then we're going to write down what the ratio is, how many minutes there are per hour. So for every 1 hour, we have 60 minutes. So from there, we're going to multiply across. I'll put a 1 here because that's empty. And then we have 90 over 60. The cool thing about this table is that you can see the minutes canceling out, and that kind of gives you some reassurance that you're converting correctly. And so that leaves us with just hours. So 90 over 60, let's reduce that, get rid of the zeros at the end. 9 over 6, if we divide by 3, 3 over 3, that's going to give us 3 over 2, which is 1.5. So that's 1.5 hours. Now that we have the hours matching, we can go ahead and multiply them together. And just because the table is so cool, let's go ahead and use it again. So it'll be 2 miles per hour. And then we're going to multiply that times 1.5 according to the rate, according to the distance equals rate times time. So 1 hour. And then here we can see the hours canceling, which is great because now we're getting the distance that we needed. And that's 2 times 1.5, 5 times 2. 2 times 5 is 10, carry the 1 over there, 0, 3, 30. And we have the decimal, so put that decimal point there, which is 3. So our answer is 3 miles. So quick recap, in order for us to find out the total using a rate and a time, the times need to match, and the best tool to use to convert either one of them is this conversion table. All right, let's get back to the main lesson. And that's it. Great job putting the work in. Like this video to let me know that I helped you out, and keep prepping for your SAT with the rest of my breakdowns. Later.